Greetings, everyone. I am Jubin Thomas. I work as a technical architect at Signet Jewelers. I'm also a senior member of IEEE. Today, the topic which I would like to discuss is building scalable e-commerce backend with microservices. And before I start with my presentation, I would like to thank Mark and all the organizers of Conference 2024, Conf42, to invite me as a speaker. As you all know that there are a lot of pioneers in the world of microservices, and some of them are listed over here: Netflix, Spotify, eBay, Amazon Web Services, Airbnb, Uber, Nike, Twitter, Walmart, and Verizon. The agenda for talk today is going over the overview and infrastructure architecture, like what are microservices, when should I use them, what is the right size for a microservice, why is microservices better than monoliths, infrastructure architecture. Then we'll go through the testing strategies, like microservices testing strategy and the testing tools used. We'll go over the Docker and Kubernetes architecture. What is a Docker? What is Kubernetes? What is a Kubernetes architecture and the Kubernetes concepts? Finally, we'll go through Node.js, Express, and MongoDB. We'll see what are the different types of Node.js available, the advantages of using Node.js. Then we will go through what is MongoDB and what is the requirement for a Node.js based microservice platform. Then we will see a simple application using Node.js. So what are microservices? It's an approach to engineering focused on building single function modules with well-defined interfaces and operations. It minimizes the risk and scope of change. It is easy to deploy and easy to understand across various business. So as you can see in this image, the left side is basically the monolith architecture, which is a typical architecture for a monolith system where there's a user interface, and then we will have a business logic in the data layer. And the data layer is a layer which connects to the database. With the implementation of microservice, the same user service is actually connected to multiple microservices. So the whole monolith business logic is actually divided into multiple microservices, and we will be having different databases for each of these microservices. Now, a question comes that what is the right size for a microservice? The business function domain of the service determines more important than its scale, which means that rather than focusing on the scale of the microservice or the size of the microservice, it is more important to understand what is the business function which that microservice will perform. One microservice might have a dozen entities and the other will have a couple of dozen entities. For every bounded context from DDD enables you to break down a big multi-domain monolith into a microservice. Emphasizing user stories will enable us to precisely outline the limits of the business domain. Now, why is microservice better than monoliths? As you see, that monolith is actually built as a single unit, as we saw in the diagram. It's basically a database backend code and front-end code. And at the same time, any feature addition requires the entire unit to be deployed. On the other hand, in microservice, we basically do a small autonomous services that work together. It's loosely coupled with bounded context. Now, the image what you see here is a typical microservice example where we have a UI layer, and then in case of a e-commerce world, we will be having 4 different entities here, like shopping cart, order, customer, inventory, and this is a bare minimum things which is required for an e-commerce background. And we see there's a database over here, but at the same time, in the microservice world, we will be having a customer, order, shopping cart, inventory as totally different services, and it could be connected to different other databases. As you see, customer could be connected to Redis, and order could be in MongoDB, shopping cart in Microsoft SQL Server, and inventory in Oracle 12c. Now, what is a capability-centric design? Usually, in a monolith manner, the team is splitting depending more on the technology or skill set than corporate goals. In business-centric development, it basically focuses on business capabilities. The entire team is aligned towards business capabilities. For example, here we have 3 different capabilities listed over here, and the product team is defined based on the number of capabilities we assign. Now, understanding the root An aggregate will have one of the component objects be the aggregate root. So for example, here in this case, order is connected to various different entities like customer, shipping address, payment strategy, and payment strategy is actually connected to credit card, cash, bank transfer. So this is a typical shopping menu, if you see over here, where there are entities, there are service ports and utils, and the adapters are something which helps to implement the database access services APIs. Converters are used to convert an enum value to proper integer value in the database. As you see, there are different adapters like order repository, order service, order web service, order query web service, shipping address web service, and so on and so forth. As we all know that CRUD, which is basically create, read, update, and delete, has its own disadvantage. A mismatch between the read and write representations of the data. It risks data contention where records are logged in the data store in a collaborative domain, and it can make managing security and permissions more complex because each entity is subject to both read and write operations. Let's go through the microservice testing strategy. So as we all know that there are many testing components, like unit testing is the smallest piece of testable software. Component testing is something having a scope of exercise software to a portion of the system under test. Integrated testing defines the communication paths and interactions between components to detect interface defects. And finally, we have an integration contract testing to see whether the contract is matching. And finally, we have an end-to-end test which tells that the system meets the external requirements and achieves its goal. There are many microservice tools, out of which some of them which I listed over here, they are pretty famous and pretty known. So as we know that JUnit is one of a great testing tool in the combination of Cucumber, and also we have Mockito to define the unit testing and the component testing scope. Now let's go through what is a Docker. So Docker, as you all know, it's an open source platform for developers and sysadmins to develop and deploy and run applications with containers. So it works on the principle of build, ship, and run. And this is a typical Docker architecture where there is a client, and then we have a Docker host, where a Docker host has Docker daemon, and there are multiple containers within that. And we do have a registry for this Docker. Going through Kubernetes overview, Kubernetes is again an open source system for container orchestration. It is focused around scheduling, scaling, and self-healing. This is a typical Kubernetes architecture where we have an API connected to the user interface and command line interface, and which is actually connected to the Kubernetes master. And a Kubernetes master could be connected to multiple nodes, as we could see in this image. And Kubernetes works with the concept of pods. So a pod is basically a logical application with one or more containers and volumes. It is having a shared namespace and one IP per pod. And a service is basically a thing which basically connects to multiple pods. So in this case, if you see a service is connected to 3 different pods. Now let me go through the microservice framework using Node.js and what is the advantage we have with this. So the advantage of creating micros with Node.js is, as listed over here, it is a single threaded microservice, and then we have bufferless atmosphere over here. It's asynchronous, highly scalable, extremely quick, event driven, and licensed. The most popular Node.js microservices are Express.js and Nest.js, and in this presentation I have used Express.js to build a simple application which I would be displaying in the later part of the slides. Now what is a MongoDB? As you all know, MongoDB is no SQL database, and what are the benefits out of it? It is schemaless, it has a lot of scalability, and it gives us a great performance benefit. Now the requirement to write microservices is in Node.js. As we all know that writing a microservice which also includes a producer, message broker, and a consumer. And with this, we will be having certain requirements like installing the Node.js, installing NPM, installing Docker, and RabbitMQ if we are using a message broker. No, I am actually covering creation of a simple application, which is basically to order a product using Node.js. So as part of this, we have 5 different files, and I'm going to the details of these files as I explain in this talk. So we have db.js, product.js, and another product.js, which is basically launching as a server. And we have a order.js, and to launch order.js, we have another order.js, which is basically the server for order.js. So what is db.js? It is creating a database connection using Mongoose. As you can see on the right side, we are using Mongoose to connect to the database, and if the connection is successful, it displays a connection successful message. Otherwise, it throws a connection is failed. Now, what is a product.js? We are creating a product service over here. So customer should be able to order a product using this microservice. So in this case, we have a product.js where we have product description as one attribute, then product name, product ID, and brand. And similarly, we create products.js, which is basically creating a server for product service. So in this, to launch this, we have a port 3000. And as you can see here, there are different app.post here, one for the product and products. And then we have app.get for product ID and app.delete for deleting a product. Now, what is order.js? It is basically giving a platform to create orders, or basically to order a product. So in this case, we have product ID, initial date, and the delivery date as part of the order schema. And order.js is another file which we create to create as a server for order.js. So in this case, we see that we have a new order.save to save an order. If an order is actually saved, we basically say a new order has added successfully. And if there is a connection error, we basically say that it's an internal server error. At the same time, we have app.get for fetching the orders. And if we have a specific order to be fetched, we can also pass the order ID to fetch that respective product. In conclusion, I would like to say that microservices in Node.js are really good for developing applications we can modify without affecting other services. Thank you so much for listening to my talk. That's pretty much which I have to share. And that is my contact information, jubin.thomas@ieee.org. I would be very happy to connect with anyone who would like to send me a request. Thank you so much.